Welcome friends. Today I'm going to discuss about must do algo questions for interviews like Amazon, Microsoft. So today I'm going to pick a problem on an array which usually is solved using min heap or a max heap. So the problem statement is find kth smallest number in an array. So first we'll discuss the problem statement, then we'll discuss all the possible solutions for it. I'll also write the code for it in GoLang and run benchmark against all the possible solution so that we can compare which algo is better and which one is not. So let's start. Let's try to understand the problem statement. So what is the problem statement? It says find the kth smallest number. So if let's say given an array of 1, 2, 7, 8, 9, 5, 4, 3. So I have to find the kth smallest number. So if let's say k is equal to 3. Okay, let's say k is equal to 3. So now the smallest number is 1, second smallest is 2, and the third smallest is 3. So my answer should be 3. If k is 4, the answer should be 4. If 5, then answer is 5. 6th is this, 7th and 8th. So how can we solve it? First of all, I'll tell you to pause the video here, think for a minute, and then we'll come back to the solution. So pause. Okay, so now I think you have already thought about how can we solve it. So the easiest approach is a brute force, right? So if I sort this array, my outcome will be 1, 2, 3, 4, 5, 7, 8 and 9. So in this sorted array, I can always find the kth element. So if it was 3, so I can go and to the second index, the third element. If k was 4, I can directly go to the fourth index. So what's the time complexity of this approach? Sorting. So the sort, you might use quick sort or merge sort. It's gonna take n log n, and so that's the worst case. So now, is there a better way to do it? So again, I'll say pause and think about it. So this is the one I've said as a brute force. So let's pause and think about it. How can we solve it? Okay, so now let's discuss the other approaches. So one is using a min heap, and one is using a max heap. So let's discuss the min heap approach. Min heap is a very easy. So what I do, I create a min heap of all the elements which you have seen. So in this case, it'll be something like 1, 2, 3, 4, 5, maybe 8, 9. So in min heap, always the top element is the smallest in the heap. So first we prepare a min heap out of all the elements and then start extracting the top. So now when I remove 1, so what I'll be left with is 2, maybe 4 comes here, 5 stays here, 8, 3, 9. And now second time I extract 2, so my top will be 3, 4, 5, 9, or actually 5 and 9 here. So this will be my min heap. So now if your problem statement had k equal to 3, so this is my answer. So I have to call extract min 3 times. So that will give me the answer. What is the time complexity of this approach? It's actually preparing the heap plus extracting it min times and then heapify. So preparing the heap, k extract mins and heapify after that. So n plus k log n. So now we are going to discuss the best approach, which is the max heap approach. So for a k smallest, I go for max heap. If it is k largest, I'll go for a min heap. So what's the solution? So the solution is I prepare heap of only k elements. So if my number was something like 1, 3, 4, 2, 5, 6. So first I'm gonna prepare, and if let's say my problem set k is equal to 3, so I'm gonna prepare for the first three element, which is 1, 3, sorry, I have to prepare a max heap, so max should be on the top. 4, 3 and 1, right? So this is my the first heap ready. So next, the next element which is coming for me is 2. So I'm gonna insert the element, if the element is less than my top of min heap, then I'm gonna pop it out and insert 2 here. So now in this case, when I pop this out, my 3 goes on the top, and when I insert 2, it will go here. So I'm not worried about what goes in the child, we are just worried about what's on the top. So now 2 is processed, now comes 5. So 5 will go inside only if it is smaller than 3, which is not, so 5 doesn't go inside. 6, same scenario, 6 won't be pushed into this heap because it's more than the 3. And now after we are done processing all the inputs, the top element of the heap is my answer. Cool, right? It's really easy. Like, it looks tough maybe when you hear min heap and max heap, but it's actually quite easy. Let's run it for a different scenario, maybe 4, 5, 6, 1, 2 and 3. So in the beginning my heap will be something like this: 6, 5, 4. These are processed, now 1 comes. So 1 is smaller than the 6, so 6 will be popped out, 5 goes here, 1 is here, 4 is here, right? Now comes 2. 2 is smaller than the 5, so 5 will be kicked out, 4 will be on top, 1 comes here and 2 is here. Now comes 3. 3 is also smaller than the top, 4 will be kicked out, 3 comes here, 1 here, 2 here. So my answer is again 3. So yeah, I think now it's time to jump into the coding and run benchmark for all the possible ways. I forgot to discuss the time complexity of this. So what is the time complexity? First we have to prepare the min heap, which is k, plus what we do. So first k element were done, and n minus k, for n minus k I call heapify. Let's say the worst scenario, every element got inserted, so n minus k and log k, because the size of the heap was k. So this is the worst case complexity for max heap approach. So now let's get to the code part of it. I have already written one heap, a max heap and a min heap. So I have also written the test cases, so that so right now if I go and run the test cases, everything should fail. So let's say using the sort approach. So you can see that all of the test cases failed for me. So let's start writing the code now. So I have first, let's try this sort way, which was quite easy, right? So first thing, let's just check whether the input length is less than k. If it is less than k, I'm gonna just return -1. Fine. Now next is quite easy. Heap.int. So it will be input, sorry, and then return input and the k -1 element, right? So now I think, yeah, this works. So let's go and test sort. Does it work or not? Let's see. Okay, so all my test case passed. So now let's jump to my second code of using min heap, right? So first thing first, I'm gonna just copy paste the check. Even actually here I can do that. And now I have to prepare a min heap, right, of all the elements. So I'm gonna make of type int max heap was my max heap actually. I need total of oh sorry, I'm gonna do it for the min heap, right? Int min heap, it should be for the total elements, so length of input, right? So now I have my heap ready. Now I just need to start appending into it. So int I starting from 0, sorry, I starting from 0 to I less than it should be full array again, right? So I have to prepare the heap for the full array. I plus plus. Now I have to just add it to the heap. So my heap is ready. After this, I just need to call heap dot init and pass the heap. Cool. So now my heap is ready. The min heap is ready. So I have to now extract the top k times. Extract the min element k times. So for heap dot pop from the heap, right? And now what is my last pop? So I did it for less than k, right? So now my answer will be this. The kth pop will give me the answer. Oh, I need to typecast it to int. Cool. So I think I have min heap also ready. So let's run the test for the min heap. So actually there was a mistake here. It should actually be k times, right? So 1 to k minus 1 and then kth should be here. So I should start from 1. So now I'm gonna go back and run my test case. Let's see how does it work. So yeah, all test case passed. So now let's jump to our most important way of doing it. So here I have to make a heap of k element, a max heap. So let's make a max heap. So it should be int max heap, and now it will be just 0 and for k. So for k elements I need to make a max heap. Let's take it as h. Now for I starting from 0 to k, let's do h equal to, just append the ith element in the heap, and after that just initialize the heap. I equal to k for the rest of the element. So first k went directly to the heap. So for rest of the element, if the number is greater than if the top is greater than the input, then pop the top and push the new element, right? So if it is greater than popping and pushing, now I just need to return the top element. Make sense? So this is how the code looks. Now let's run the test case for the max heap. So yeah, all test case passed. So now let's go to the benchmarking of all these three. So how I'm preparing a input for the benchmark is I have 100 elements and I'm gonna run the benchmark to find the kth smallest element. So I have created this benchmark test. I'm gonna run the benchmark for this complete and let's compare all three together. So run benchmark for all three approach. Okay, my benchmark is also ready. So the one with the sort took 2148 nanosecond per operation. The one with the min heap took 1822, and the one with the max heap took 329 nanosecond per operation. So yeah, looks cool. I'm gonna run the benchmark again. Let's see what's the result. Okay, the results are out. It looks quite similar to the previous one. So yeah, I think yeah. So I think I'm done. We have seen which approach is the best one, and which one is the worst one. If you have a better solution than these three, please let me know. Put the solution in the comments. We'll see you in the next video. Thanks for watching. Bye bye.